So after a week of break, I'm resuming my TensorFlow developer certificate and now with time series data with TensorFlow. So what is time series data is we have, all the data we have seen until now. One of the columns is time, as simple as that. So this turkey's life's well-being, if we plot it as a graph as a function of the day, we have its quality of life is pretty good. It starts excellent from day one to day 1000 until it's time to cook the turkey. So this time series data, it has two patterns. One pattern until day 1 to 1000, and then completely different pattern at one this thing, which is the unexpected event. So time series, generally how we perceive it is like if there is a pattern to be learned from the past, which can be projected into the future, it is a time series data. But if there is none, we can't predict that surprise. We couldn't predict recession. We couldn't predict, let's say, when banks melt down or something. So it's kind of like there is a lot of power and potentially high financial reward if you get the time series prediction right. But if you don't, the random prediction which is not found in any past pattern, that cannot be tracked here. So that's the time series data. How is that data different from the data we had for computer vision or NLP? It's almost the same. There is going to be one column which has timestamp as well. So we measure all the instances of the data with respect to time. So its rate of change or changes with respect to time for things. So if we could monitor health, we could monitor financial health, whatever it may be. So effectively, all the components we have seen until now, whether it is data set, building the model architecture, training the model, evaluation of the model, writing the code, that whole end-to-end process we have done, it all remains the same. It's if it is vision, the data set prep is a tiny bit different. If it is natural language, it's tiny bit different. There are some extra pre-processing steps we have to do. Similarly, time series, it is almost the same. Everything remains the same. So what does change is there are a few terms. So these are the lingo for time series data science part. Two key being horizon and window. So horizon is the horizon of future. So future, it is kind of also like the video game Horizon Zero Dawn. It's a game based in future where we are trying to do something. It's an amazing video game. It has a very good AI a feature, AI as a part of storyline in that game. It's just amazing. So horizon is that future and window is the past window from which we are going to predict the future. So if we say window size as 7, then past 7 time stamps data is used to predict horizon, future horizon, which in this case it is 1. So we have horizon of as 1 and window size here as 7. So can we predict the next 1 day horizon, 2 day horizon, 3 day horizon with respect to the past window of 7 days or 10 days or 15 days, 6 months, 12 months, whatever it may be. So this is how it is. Farther we go into future, more difficult it will be to do prediction, and more the window size, better the pattern can be processed to do whatever prediction we want to do. So these are a few important terms. And then next terms, these terms are about the nature of the time series itself. So the trend, the word trend, seasonality, and autocorrelation. So three more important terms. Trend is the general trend. So it's like generally it is increasing. So if we talk that simple linear incremental thing, that is the trend of time series. So in Coursera, TensorFlow developer certificate, it goes into these concepts a lot better than TensorFlow zero to mastery course alone. So I'm taking those graphs. So if I plot trend is something like this, incremental trend or decreasing trend, whatever it may be, it's a continuous trend in a certain direction. That's trend. Then we have seasonality. Seasonality is data in which there is a predictable cycle. It repeats. There is a season, so same thing repeats after the season is done. So you see here, if we take a look at this spike, nature, from this point to it goes, there is this spike, then decay, then there is another short spike, and then again decay. So this part from this to this, I wonder how I can maybe if you take a look here, this is constantly repeats. So this is the seasonality. Trend is the long term trend in a certain direction. Seasonality is how it repeats. And then the third type is autocorrelation, wherein we do have the signal as is, but we also have that signal is, it comes with a bit delay and a bit more decreased amplitude. So that see autocorrelation is, there are random spikes, and the data dampens over time. So we have trend, seasonality, autocorrelation, three things. We can have data with a trend without seasonality. So long-term trend we can have. We can have trend with seasonality, so predictable cycles with a trend. So over time it is going to increase. You can see that here in graph. So you check, this is a predictable seasonality, but also with a long-term trend. Generally, when we are doing any business over time, things, if we have an increasing customer base, increasing turnover, so these generally are population growth. So we have an incremental trend alongside same seasonality also. So this is a permutation and combination of nature of the time series data. So think of trend without seasonality, seasonality without autocorrelation with autocorrelation, and see how conceptually they are different. So these are the time series terms, and in general, it's in terms of modeling code and everything, it is almost the same. Just a tiny bit terms and tiny bit changes, but the experimentation thing we do, how we write the code, all of it, most of it remains the same. The process just tiny bit different. So this is time series, and now applying this data to time series data, I'm going to do that to a Kaggle competition where I'm going to take EEG data, brain's activity data, and try to do prediction. So based on the waveform which has been measured, whether a person is getting a seizure or not. That is how that Kaggle competition is, and it is a real life problem. So if you check. Mhm. Yes, harmful brain activity classification. It's a time series problem, a real problem with a real life use case in which winning does give you a financial reward, and it is from Harvard Medical, so very high quality thing. So taking this theoretical things, applying it to this, and making it functional. That is how I'm going to move forward with TensorFlow developer certificates. Final part of this time series thing.